Hello class, welcome to lesson 9.1, which is all about graphing quadratic functions. By the end of this lesson, you should be able to analyze the characteristics of graphs of quadratic functions, and you should be able to graph the quadratic functions. So let's jump into talking about what a quadratic function is. So the parent function of a quadratic function, meaning like the most basic version of a quadratic, is the graph of x squared, okay? So you guys probably remember seeing those U-shaped graphs. Those are called quadratics, or we call those parabolas. The type of graph is a parabola. It happens when you have that squared right there with your variable. So the standard form, it's very important that you remember and pay attention to this. Standard form is when you have f of x equals ax squared plus bx plus c. This isn't anything new. This is what we've been talking about, but I want you to really focus on having your equations written in this form, okay? A couple of new, or I'd say the newest thing here, is talking about the axis of symmetry. Remember, symmetry is when you can cut something in half. So if I were to draw that vertical line, if I were to fold on that line, if my drawing was perfect, it would fold exactly in half. If you look at the drawing up here on the key concept box, you can see that the red dotted line is the axis of symmetry. A couple other things it points out is the vertex. The vertex is either the highest or the lowest point on the graph. It's kind of where that U turns back around, okay? And then the last thing, that just a quick refresher, the y-intercept is always represented by that last number without a variable in your equation. So if you had f of x equals 3x squared plus 2x plus 3, your y-intercept is that 3 on the very end there. If you just had a 3x squared plus 2x, your y-intercept would be 0. It's like having a plus 0 there, but we never write plus 0. So even if there's no number there, doesn't mean that there's no y-intercept. It just means it'll intercept at 0. Okay, so let's talk about graphing a parabola first. Let's practice using a table of values in order to graph the equation y equals 3x squared plus 6x minus 4. Then we want to state the domain and range. So let's start by graphing it. So if I plug negative 2 into that formula, I have 3 times negative 2 squared. So negative 2 squared is negative 2 times negative 2, positive 4. Positive 4 times 3 is 12, plus, and then we have 6 times a negative 2 is negative 12. And we have a minus 4, not 14, minus 4 on the end. So positive 12 plus a negative 12, those cancel out. I'm left with a negative 4. And then if I go through and I have negative 1 times negative 1 is positive 1 times 3 is 3, plus negative 1 times 6 is a negative 6 minus 4. So I end up with a negative 7. And if I go through and do all of those, I end up with these points. So I can go ahead and find these spots on my graph. So negative 2, negative 4 is right here, negative 1, negative 7. Then I have 0, negative 4, 1, 5, and then 220 goes way off my graph. But the cool thing with parabolas is I know that it is symmetrical. So that means I can figure out that there would be another point right there. So then I'm going to connect my dots. And I have a parabola there. So I've graphed it. Now I want to finish it off by stating the domain and the range. So my domain, remember, domain has to do with the variable x, range has to do with the variable y. So if I were to keep going, I could plug any number in for x and get a number out for y, right? So my domain for basically all of our quadratics is going to be all real numbers, because I can plug any number in and it'll work. you still have to write that down, okay? That's not something that you can just say, oh, it's always the same, I don't have to bother mentioning it, because in the future, it's going to change, but right now, I'm telling you, it's going to be all real numbers. The range, however, what kind of y values do I get? I see I have some positive y values, and I also have some negative, but if I look, this graph is never going to go below that point, the bottom of that u. So for my range, I'm going to say y is greater than or equal to -7, because it touches that -7 and then it goes to anything above it. So that is my domain and range. Why don't you go ahead and try solving this one on your own and see how you do. Hopefully you determined graph A was the correct answer for this. If not, be sure to ask for some help. Okay, now let's talk about identifying characteristics from graphs. So we want to be able to find the vertex. We want to be able to find the axis of symmetry, the equation for it. And we want the y-intercept of each graph. So if I just give you this graph and I say, what is my vertex? You should look, you should say, well, there's the highest point on my u, so that's going to be my vertex. And that point is -1, +3. Then the axis of symmetry, if you can't tell from the graph, we have a line right here, and you might be able to know that the axis of symmetry, you'll see me abbreviate it to AOS, axis of symmetry is going to be where I have a vertical line, so I know that equation is going to be x equals -1. The way to find your, actually we'll talk about that later, and the y-intercept, we want to know where does it cross the y-axis. Crosses the y-axis at 2. So that's the information I am looking for when I give you a picture. Let's try just one more. My vertex in this one is the lowest point of the u. So I know my vertex is at 1, 3. My axis of symmetry, my vertical line is always going to be at x equals, and in this case it's a +1. My y-intercept, where does it cross my y-axis? 1, 2, 3, 4 is 4. Okay? And why don't you go ahead and identify the equation for the axis of symmetry. Hopefully you determined that x equals 1. If not, be sure to ask for some help. Try to find the coordinates of the vertex. Hopefully you determined that this was 1, -2. Like I said, if you have questions, be sure to ask for some help. Well, let's move on to being able to find the vertex, equation of axis of symmetry, and the y-intercept when you don't have a graph. So let's start by talking about what do we know. We know that we want the vertex, we want the axis of symmetry, and we want the y-intercept. So the y-intercept is typically the easiest one to find because it's just written there for you. You don't have to do any calculations. It's always that c term. Remember, this is our ax squared plus bx plus c. And here, our c just happens to be a -5. Now, our axis of symmetry, the way we find that, our equation is x equals -b over 2a. So if I look, I have x equals that -6. What's my b value? My b value is 6 over 2 times a, which is -3. So I have -6 over -6, which is a +1. So I know my axis of symmetry is x equals 1. And my vertex, the way that we find the vertex, you take your axis of symmetry, okay? So this is your axis of symmetry, and then if you plug your value from the axis of symmetry into your equation, anywhere there's an x, you will get your vertex. So I have negative 3 times 1 squared is negative 3 plus 6 minus 5. So that's 3 minus 5, or negative 2. Okay, so I wrote my y-intercept. Then I found my axis of symmetry using the equation. Once I had my axis of symmetry, I plugged it in for x for my vertex, and then I plugged it into the equation in order to figure out what y was. Okay? Why don't you go ahead and see if you can find the vertex for y equals x squared plus 2x minus 3. Hopefully you got negative 1, negative 4. If not, that's okay. Why don't you try one more? For this one, hopefully you got x equals 0.5 or 1/2. If you have questions, please be sure to reach out for some help. Alright, so we're just going to briefly talk about the difference between linear functions and quadratic functions. Linears are the y equals ax plus b, or we usually call it y equals mx plus b. That's when you have those lovely straight lines, okay? A graph, you get a line. All of the variables are to the first power. So this x, it's like it has a 1 up there, but we don't write that 1. Quadratics are slightly different. We have 3 terms. Sometimes we have 2, but the most important thing is that you have that second power. You have that second power, and then you get a parabola. So you get that u, or the upside down u from it. Okay, so let's talk about a little bit more detail our parabolas. So if you have a graph of the form ax squared plus bx plus c, you're going to have either a regular u or an upside down u. When it opens upward, that is because you have a positive a value, or I guess it's lowercase a. If it opens downwards, it is because you have a negative a value, okay? So a is positive, a is negative. When it's a positive a, if you look at the graph, our vertex is the lowest point on that graph. When a is negative, it's upside down. That vertex is the highest point, so it becomes a maximum. So we call those vertices minimums and maximums on parabolas. So I'm going to ask you to be able to identify, is a graph going to have a minimum or a maximum? And I'm going to ask you to tell me what that is. That minimum is going to be, you'll have an x, and then it's going to be whatever your y value is. For the maximum, it's going to be your vertex, so the x value, and then whatever your y value is, okay? So if you find the vertex, you can tell me exactly what the minimum and maximum are. So let's consider the function g of x equals 2x squared minus 4x minus 1. We want to determine whether the function has a maximum or a minimum. So if I want to know if it has maximum or minimum, I just have to look at that a value. I have a positive a value. So if I go back, positive a means that I have a minimum. So I have a minimum. If you just want to write min, that's totally okay with me. If I ask you to state the maximum or minimum value, this is where we have to find our vertex first. So we start with our axis of symmetry. So that negative b over 2a. So then that is a negative. And then our b value is negative 4 over 2 times 2. So I have negative I have a negative and a negative, so I'm going to say those become positive. So I have a positive 4 over a positive 4. So the axis of symmetry is 1. If I want to find the other part of my vertex, I just have to plug it in. So I say g of x equals 2 times 1 squared minus 4 times 1 minus 1. So 2 times 1 squared is 2, and then I have minus 4 minus 1, or I have a negative 3. So I found my vertex, and the reason this helps me is the y value tells me what my, in this case, minimum value is. So I would say my minimum value is negative 3. Next, we're going to talk about the domain and range. I already told you your domain should be all real numbers, and your range depends on where your vertex is. So in this case, we have y, and we know it's going to have something to do with that negative 3, but is y going to be greater than 3 or less than or equal to 3? If we have an upward parabola, that means my vertex is here, so all of my y values are going to be above it. So y is greater than or equal to that negative 3. Go ahead and determine whether this has a maximum or minimum. Hopefully you said minimum because of positive a. Now state what the maximum or minimum value is. Hopefully you got 6. And the last step, state what the domain and range is. Hopefully you got the domain with all real numbers, and the range is y is greater than or equal to 6. Alright, so when it comes to graphing quadratic functions, there are just 5 steps for you to follow. The first step, find the axis of symmetry. So use that x equals negative b over 2a in order to find your axis of symmetry. Because if you're graphing, you can't just look at a picture because you are making the picture. Then find the vertex. Figure out, is it a maximum or a minimum? Step 3, find the y-intercept. Again, that one should be fairly easy. Then step 4, use additional points to graph, meaning make yourself an XY table and graph from that. Step 5, connect the dots. So all of those different points you've graphed in steps 1 through 4, now connect them. Make it a single graph. I highly recommend writing this down somewhere to help you remember the steps. Alright, example 5 is going to be the last one that we do together. So we have f of x equals negative 2x squared plus 2x minus 1. Our axis of symmetry, we have x equals negative, and then our b value is 2 over negative 2 times 2, or positive 2 times negative 2, sorry. Either way, we get the same thing. So we have a negative 2 over negative 4, or a positive 1/2. And so I know I have an axis of symmetry at positive 1/2. So I'm going to do just a dashed line because I know this is going to cut my graph in half. Okay? Now, I want to know, is it a maximum or a minimum? I have a negative a value, so that means it's going to be a maximum. That means it's going to open downward. I know my x value is 1/2. If I plug 1/2 back into the equation, I get negative 2 times 1/4, which is negative 1/2, plus, and then 2 times 1/2 is just 1 minus 1, so I get negative 1/2. So my vertex is at 1/2, negative 1/2. And then I have my y-intercept, which is at negative 1. And since I know it's symmetrical, I know where another point will be on the graph, and I can plug in a few other points. So if I plug in, let's go with a 2. If I plug 2 in, I get a -5 out. So if I plug in 2, I get 1, 2, 3, 4, -5, and I know it's symmetrical. So now I can just connect my dots, draw some arrows on the end, and I am done graphing. All right, why don't you go ahead and graph the function x squared plus 2x minus 2 and see what you get. Hopefully you ended up with something that looked like graph C. If you have any questions at all, please be sure to reach out for some help. I know graphing can be a little tedious, but just do the best you can. And be sure to reach out if you have any questions. Have a great day.